has a vertical asymptote at x equals 0 because that's what makes the denominator 0, so we'll have a vertical asymptote at 0. Because the bottom is 0, it will have a horizontal asymptote at y equals 0. And it's going to have the shape of the graph 1 over x, and that we already see over here. So it's going to look something like this. Well, notice that this original function's domain is going to be a domain of negative infinity to 0, union 0 to infinity. And its range should be the same, negative infinity to 0, union 0 to infinity, because there's also a horizontal asymptote at 0. Now again, notice that whatever was the domain should become the range of the inverse, because we're going to swap our x's and our y's. And then whatever was our range of the original function should become the domain of the inverse, because again we're switching our x's and our y's. Question is, how do I find the actual equation for the inverse? Well, we take our original equation and we'd swap x's and y's. Well, we'd replace the y with an x and the x with a y. That would look like x equals 4 over y. How would you solve this guy for y? Well, you'd have to get y out of the denominator by multiplying both sides by y first. That would get us xy equals 4. So to solve for y, we divide both sides by x. Well, that's weird. We're getting the same equation we started out with, and we did not make a mistake. That means the original function and the inverse are actually the same function. So that means our inverse, running out of space here, our f with the little -1, the inverse symbol, is 4 over x, the same as our original function, which makes sense as to why their domains and their ranges are the same.